Hey gang, Tim here at Core Electronics, and today we're creating interesting animations in Python using the turtle library and finishing it all up with a turtle race. It is time to flex some of those coding muscles we've gained. The first codes in this guide will be generators for geometric shapes. These scripts all use the functionality from the turtle standard library. This is pre-installed into Python by default and is a graphical library. Then the last script in this guide will generate a turtle race, perfect for an afternoon coding session. Thus, this guide will ease you into the first steps of coding with an objective. Now, think of the turtle library as a whiteboard with a small robot turtle situated on top of it. The window that opens up when you run code through the turtle library can be seen here, which is also on our Core Electronics tutorial page. The robot will leave a pen line behind itself whenever it moves. The size and dimensions of this pen line can be pre-decided in your codes. And also, the robot turtle can be controlled in your code. Thus, by commanding the robot turtle to move, you can draw lines all over the board. Now, this whiteboard is a pop-up window which will be white unless otherwise specified. The following scripts will all introduce control methods for the robot turtle and different options available when utilizing the turtle window. There is no end to the number of interesting patterns and geometrical shapes you can create using these methods. All the codes and more can be found on our Core Electronics write-up page. To allow your codes to access the functionalities of the turtle library, you must utilize the import keyword. So let's jump into some code. First, we'll start by drawing a blue square with our robot turtle. Starting off, we import the turtle library, just like that. Now we're going to decide the color of our turtle. It's the American spelling of color, and our turtle will be blue. This is going to decide the line. Now the way the turtle moves is it moves a certain amount, and then you can change the angle. So I'm going to move the turtle forward 100, and that's 100 pixels. Then I'm going to get the turtle to go right 90 degrees. So as you can imagine, it's gone forward and now it's turned. So what we're going to do is repeat this process, moving forward, turning, and then 2, 3, and then one final turtle dot forward 100. And just like that, when I run this code, so that was easy. So now let's create another script which will draw us an octagon, which also uses a while loop. So demonstrate that you can use looping structures inside the turtle library. So once again, import turtle, and this time we'll make the turtle color green. Nice. So what we're going to do is set up just a variable, and now we're going to use that variable we set up to make a loop. So it's going to go around 9 times, and then we're going to go turtle.left 45 degrees, so starting off by turning, and then we're going to go turtle.forward 60, and then we'll add up a little tally for I. So that way I will be how we escape this loop once I gets above 9. So going quickly back and fixing the one section of code, making forward actually say forward. If we run the code now, save it, you can see our octagon. Finally, we're going to create a star shape. Once completed, the enclosed area of that star shape is going to be filled in with a yellow color. I'll create an infinite loop with a break statement enclosed so that the loop can end. This break statement will be triggered in the code by an if statement, which will stop the robot turtle once it's returned to the starting position. But enough talking, let me get into it. So once again, we're going to use import turtle, but this time we're in fact going to change this to from turtle import star. Now this will just give us the functionality that we need for this particular code. It also means that the syntax when using the turtle library will be slightly different. No longer do we have to say turtle before all our functions. So red and yellow. So what's going to happen is the line's going to be red and the fill's going to be yellow. So you can begin the fill using this function there, begin fill. So the begin fill is tied in with another function called end underscore fill. So begin fill is going to look for all the enclosed spaces, and then end fill, it fills in those spaces. So we're going to press enter a couple of times so end fill happens once we've completed our geometric star. So now we're going to go while true. So this makes an infinite loop. We're going to go forward, spelled correctly, 200. Then we're going to go left, 170. And this is all pixels. Then our if statement to get out of this infinite loop. This is going to look like this. The absolute position becomes less than 1. This effectively means it will stop once it gets back to its beginning point. And at this, we'll use break. And this gets us out of the loop. Then we're out of the loop and fill. So for those with a keen eye, the two things I needed to change in my code to make this run is to use the correct syntax here and here. Got to use a capital letter for this Boolean value. So when I press run module now, you can see the star shape is beginning to take shape. And it goes around again. And then it fills the whole inside with yellow. Very rewarding. And with that, give yourself a pat on the back. All the starting steps to learning how to use the turtle library are complete. So now we can program a turtle race. So let's get right into it. We're going to import all our extra functionality at the beginning of the code. So we're going to need time. We're going to need turtle, naturally. We're going to need from turtle, import turtle. This means we can use simplified syntax. And we're also going to use the random, but only a particular part of random, in this case, random integer. All of this you'll see as we go through the code. So with all these imports done, we will now start setting up the pop-up window. So window equals turtle.screen. This needs to be a capital letter. Window.title. So this is the title. So we're going to say turtle racing occurring in this pop up window. Nice. Then we're going to go into what the actual turtle screen will look like. So this is the background color now. The background color we're going to make green. Because it makes sense for the turtles to live in a green world. Now this turtle that's doing this, we're going to give a color. It's going to be white. Now we're going to say turtle speed equals 0. Turtle.pen up. This is a new thing. Basically, we're taking the pen off the page and we're no longer drawing. So the turtle's off the page. Then we're going to set the position of the turtle. Then we'll give the actual page a title. So I reckon, and this title is based on where the position is of the turtle currently. So that's what we're going to say. Come on, come on, it's turtle racing time. We now have to pick the font. In this case, Arial. can be size 30, and we can also make it bold. And then turtle dot pen up. Nice. So one quick fix, once I make this T a capital T, run in the module, you can now see, come on, come all, it's total racing time. And this area is where the racing is going to occur. You can also see total racing occurring in this pop-up window. These are all the things we've decided in the code thus far. Closing this for a sec, getting back into the Python programming window. So progressing in, these turtles need some kind of dirt ground to race on. So let's do that right now. So how are we going to start doing this? We're going to start doing this by turtle.setPosition, and we'll put it on the far left side and a little bit up. The ground's going to be brown, so we'll tell the ground just that. I'm going to scroll down a little bit. So this is all, by the way, setting up the dirt. Now we're going to go turtle.begin fill, and this is what we saw before in the star example. Turtle.pen down. So now we're starting to draw. We're going to go turtle.forward, and we're going to save this number. Then we're going to go turtle.right 90, and we're going to copy and paste this because we're going to make a square. So we're basically doing what we did in the first one, except with different values. Classic, doing the same thing twice. Forward. With that, we've completed our square. It's kind of like CNC programming. Go here, go there, go here, go there. And now we're going to say turtle.end_fill, bracket, spell end correctly, and checking back through what I've written, changing this because it didn't have a necessary T, run module, press OK. And just like that, you can see we now have dirt for our turtles to race on. So every good race needs a finish line, and finish lines are normally checkered white squares. So let's do that. This is going to introduce a new functionality of the turtle library. So first we're just going to comment making the finish line. So we're going to set up stamp size to equal 20. So this lets you stamp effectively little spots. Square_size equals 15.5. So now we're not stamping little spots, now we're stamping squares. Finish_line equals 180. This is where the finish line is going to start. Now we're going to decide the finish line color. Because we need a turtle to effectively draw this for us, we're going to change the turtle color to white. You can also, interesting enough, change the shape of the turtle. In this case, we're going to make it a square. Turtle.shape size equals square_size divided by stamp_size turtle.pen up. So just like that, we managed to define a single square, a white square. So now what we're going to do is we're going to use 2 loops to make 14 white stamps all the way down, and that's going to make a finish line. So we're going to set up these 2 loops now. This may look a little bit complicated, but really what we're doing is saving ourselves from typing out every single location for these stamps. So that's one of them. And now we'll do for J in range 14. As you can see up and above, this needs to be a range, so I need to fix that, which I have. And this one also needs to actually stamp each time, because otherwise we're just figuring out the location where we're going to stamp and not actually stamp anything. So that one's complete up there. Turtle.set position. So this is where the stamping is going to begin. Finish underscore line plus square underscore size. Bracket 22211. Take square underscore size. Bracket take bracket J times square underscore size times 2. 1, 2, 3. That's all that closed up. Turtle.stamp. Now I know that seemed like a lot going on, but when I run this code, after checking through it all, you can see now we have this beautiful finish line for our turtles to go to. Now with that complete, we get to make effectively the stat blocks of our turtle competitors. So, turtle number 1. Turtle stat blocks. Turtle 1 is going to equal a turtle. So that's set up that is a turtle. Turtle1.speed. At the beginning, we're going to write 0. And we're going to write turtle1.color. Let's make this one black. Then we're going to go turtle1.pen up. So that way, getting to where I want it to start won't end up drawing a line. 1.go to. And this is his racing position at the very beginning. Turtle1.pen down. And just like that, our turtle's going to be situated there, ready to race. So what I'm going to do is copy this, go down here, paste it once, paste it twice, and paste it 3 times. 1, 2, 3, 4. Now there's going to be 4 race competitors, so I'm just going to alter this real quick. So that way we know that this is turtle 2, this is turtle 3, and this is turtle 4. All these turtles should have good names. Perhaps Michelangelo, perhaps Crush, perhaps Franklin the Turtle. These are all names that you can definitely give to your turtle races. So we'll also go through, change all the colors of all our turtles, so they're all different, and we'll also put them down beneath each other. So that way they all start at the same latitude, but they're at different longitudes. Turtle 2 can be yellow. This one can be light blue. This one can be orange. So they're all starting at -275. That's the beginning of the race, but they can all be sequentially underneath each other. So first one can be at 140. This one can be at 60. This one can be at -20. And this one can be at -110. Just like that, we have all our turtles all set up. So now, if I were to press the run, you'll be able to see all the turtles lined up, raring to go. So the final step is deciding the speed at which these turtles will go, and also at the point when the race will end. And we'll do both of these with a loop. So for I in range 145, what we're going to do is say turtle1.forward random. This is where the random integer comes in, which we imported at the beginning of this. I'm also going to do the same for each of the other turtles, but to save time, I'll copy and paste them, and then I'll go down and alter this. This is also a good place to program in unfair advantages if you want a particular turtle to win every single time. And just above this, we're going to type in time.sleep3, so that way there's enough time for everyone to put their bets and wages in, and all the turtles can get ready to go. And the very last thing, to make it really easy to get out of, we're going to do turtle exit on click. Great. Spell turtle right. Turtle. And that means whenever you click on the screen, anywhere inside the window, it will close. So we're going to have a quick look through our code before we run it, just to make sure everything's correct. One of the things I need to do is give these turtle a shape. I didn't do that. So if we go turtle1.shape and then give it naturally a turtle shape, and do this for all of them. So now they all have a turtley looking shape. And then looking through the rest of the code, everything seems okay. So what we're going to do, we're going to run this module. It's going to open up the idle shell. It's going to open up the window. It's going to wait 3 seconds, and then it's turtle racing time. Nice. Light blue's taking it. Oh, but I don't know. Light blue was close, but I think orange actually won that one. So I think this is pretty cool. I hope this has inspired some coding adventures, and until next time, stay cozy.